What do we mean by total surface area? The total surface area of a three-dimensional object refers to the sum of the areas of all the surfaces of the solid. Suppose we wanted to know the area of a die whose edges are 10 centimeters. Of course, we know that the die is actually a cube. We also know that the cube has 6 faces, each one in the shape of a square and therefore equal. So to determine the area of the die, we need to find the area of one face and multiply by 6 to get the total surface area. Since the formula for the area of a square is length times length, or length squared, the total surface area of the cube would be 6 times length squared. And so to find the area of the die, we would get 6 times 10 squared, which would give us 600 centimeters squared. Suppose we already know the total surface area, but need to find the length of one edge. For instance, the area of a jewelry box is 384 centimeters squared. This jewelry box is in the shape of a cube. What is the length of an edge? Since there are 6 equal faces, we first divide the total surface area by 6 to get 64 centimeters squared, giving us the area of one square face. Then, to find the area of one face, we find the square root of 64, which gives us a length of 8 centimeters. But what would be the total surface area of a shoebox whose dimensions are 15 centimeters by 20 centimeters by 35 centimeters? The shoebox, like the die, has 6 faces. However, the faces are not all equal. Only opposite faces are equal. So if I find the area of the top face, it would be equal to the bottom face. The area of the front face would be equal to the area of the face at the back, and the two side faces would be equal to each other. The total surface area of this figure is found from 2LW plus 2LH plus 2WH. Another kind of prism is the triangular prism, also known as a wedge. Yes, that's right. Think of the wedge we use under a door. As the name suggests, it has a cross-section which is in the shape of a triangle. Let's say this wedge has a length of 20 centimeters. Its cross-section has a base of 8 centimeters and a height 6 centimeters, with the third side measuring 10 centimeters. How would we find its total surface area? The wedge has 5 faces, 2 triangular and 3 rectangular. Looking at the cross-section, we see that it is triangular. So we find the area of the triangle, which would be half times 6 centimeters times 8 centimeters equals 24 centimeters squared. Next, we find the area of each of the rectangular faces. 10 centimeters by 20 centimeters, 20 centimeters by 8 centimeters, and 20 centimeters by 6 centimeters. Therefore, the total surface area of the wedge would be equal to the sum of the 3 rectangular faces and the 2 triangular faces. This gives us 528 centimeters squared. The pyramid is another type of solid object whose surface area we can easily determine with the use of formulas. We will look at the pyramids that have a triangular base or a square base. A triangular base pyramid is called a tetrahedron. And to determine its total surface area, we find the area of each triangular face and sum these areas. The same principle applies to a square-based pyramid. We find the area of the square base and add this to the areas of the 4 triangular faces. Another kind of solid object is the sphere. What everyday object can we think of that is spherical? How about an orange? If we have an unpeeled orange with a diameter of 7 centimeters, how would we find the total surface area of the skin of the orange? Due to its circular nature, the orange has a total surface area formula which is equal to 4 pi r squared. So after we find the radius of the orange, which happens to be 3.5 centimeters, we can find the total surface area of the skin, which is 153.86 centimeters squared. Now all of the objects for which we have calculated total surface area have been based on standard geometric shapes, for which ready-made formulas exist. But just as we combine formulas for different geometrical shapes when calculating the surface areas for a wedge and square-based pyramid, so you may encounter objects that require not only the use of more than one formula, but even some ingenuity in adjusting these formulas to determine the actual surface area. Until our next lesson, I am Renee Brown.